Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello, welcome to Pytorch tutorial series. In the last video, we finished up with our class definition of dual LSTM tagger, which is trained on the NLTK's tree bank tag sentence space, and we created 3 vocab libraries: word to index, tag to index, and cat to index. Today we shall build a model to train on those. We train on the whole input series of tagged sentences, and we pass model equals to dual LSTM tagger. We pass the word embedding dimension, that is 1024, word hidden dimension, that is 1024, char embedding dimension, that is 128, char hidden dimension, then vocabulary size, char vocabulary size, tag vocabulary size. We pass it to the GPU. Loss function is negative log likelihood function. It's a very good likelihood function, as we saw in one of the previous videos. When you double click on it, Google Colab gives you a helpful note about these options. So it says the negative log likelihood loss is useful to train classification problem with C classes. We can also use cross entropy function, but NL loss is a better option here. Our optimizer is Adam. We are taking one sample sentence that says everybody eat the food. I kept looking out the window trying to find the one I was waiting for. And then we are checking before training the model what is the output of this, and this is done here, as in we are converting the sequence of sentences into tensors, and then first we convert each word, then we convert the whole sentence, then we create a tag score from model.sentence. I'll remind you that the model is untrained, but since it has some basic LSTM structure, it will generate something, but it won't be accurate. Then I'll create the torch.max, that it's basically the argmax function, as in it tells you the tag that has the highest probability. If noun has the highest probability, it will show noun. If pronoun has the highest probability, it will show pronoun, etc. Then finally we return the output and we see what it gives. And after that, just to compare, so that we can compare after training, we are now training the model, and then we again print and see what changed. So I have an accuracy list, loss list, interval, number of epochs, which is 70. I have intervals, as in epoch intervals. Anyway, I am keeping track of accuracies, losses, and finally we are doing the same thing we did here. We are doing the same thing here, creating tensors of words, creating tensors of sentences, and finally we are creating the targets. And then our model.0_grad, that basically initializes all the gradients. After each backpropagation, we are generating a tag score. Then we are comparing the loss function, which is negative log likelihood function in this case. In loss.backward, we calculate the backpropagation. Optimizer.step updates the weights and biases after each epoch. Loss is cumulative. We are calculating the cumulative loss. Then finally, we are outputting the parts of speech with the maximum probability, and we are keeping track of all the accuracies and losses after each epoch. So we shall run it now. Okay, guys, so our model has been trained. You have finished training the model, and we can jump into the results. You might remember that we were generating the prediction for this sequence of words or sentences. Everybody eat the food. I kept looking out the window trying to find the one I was waiting for. And before training, it gives the tags as everybody as pronoun, eat as num, the as num, food as conjunction, dot as I don't know what this one is, I is pronoun, kept is something, looking as I think preposition, out as determinant, the is num, so all wrong, right? Because the model is untrained. And after I train the model, you can see that trend here. How is it going? You can try to run more epochs, maybe 140, 150, whatever you think is good, depending on your data set. Just remember one thing, the accuracy should increase at after each epoch. So if you're not sure about the trend of the accuracies for each epoch, you should plot the data using matplotlib like I have shown in the previous videos and try to figure out whether your training model is going in the right direction. So now that our model has been trained on a huge dataset and for 70 epochs, I'm pretty confident that we can predict the tags properly this time. And to make sure that we are comparing with the same results, we will run the trained model on this sentence again. And this time when we run this, our generated tags are everybody as noun, eat as noun. This should be verb actually. The as determinant, correct. Food is noun, perfect. Full stop is full stop, of course. I is pronoun. Kept is verb. Looking as determinant. A small mistakes, if you run for 140 epochs, these mistakes will be solved. Again, the as determinant, window as noun, comma as thought, trying as verb, to as I think preposition or something, find as verb. So it's much better, and I think it's giving almost 96% accuracy this time. Of course, you cannot reach 100% accuracy, but if you run more epochs, you will be closer to it. And just for fun, I'm converting this thanks for watching sentence into the uh, tags, sequence of tags. So thanks has been converted into adjective. For is preposition and watching is noun. So I'd say not bad. So once again, guys, we have the trained model on tagged sequence of words. This model will not only be used for generating tags and checking how the tags are, it is also used for word prediction in Gmail or any other places where the machine needs to fill up a sentence or generate a word. And to do that, it needs to first understand which parts of speech goes after the present parts of speech. And like this, the machine first generates tags and try to figure out which word has the highest probability in that tag space. Thanks for